Okay, activity 9, I have 5 milliliters of hydrochloric acid to the test tube. The temperature was 22 degrees and it's clear color. I've cut 0.5 of a centimeter and it is silver, and I'm gonna add it to the test tube, and there's fizz. And insert the thermometer. It's still the same temperature, but there's fizz. That's a chemical reaction, kind of like carbonation. At the end of activity 9, the temperature rose to 30 degrees, and there was still fizz if the magnesium ribbon was inside the solution. For activity 10, I have the 2 test tubes, and I will add 5 milliliters of copper sulfate. Okay, for activity 10, I have 5 milliliters of copper sulfate that I will add to 1 test tube. And I will add 2 grams of table salt. Or tar. 2 grams of table salt. Oh, went too far. Okay. 2 grams of table salt to the second test tube. Okay. And the temperature of the copper sulfate is 24 degrees. Okay, I'm gonna add the solution to the salt. Gently swirl and insert thermometer. 22 degrees so far. Reserve for 1 minute. It's still 22, so the temperature decreased. Uh, 20 more seconds. Close to the bottom of the tube, it looks slightly green. And it is divided. There's a blue portion on top and the solid on the bottom. But the temperature stayed the same. And that was a physical change because there was no new combination or product. For activity 11, I have cut several pieces of aluminum from the dish I used in activity 4. The color is silver. Okay. I'm gonna measure the temperature again of the solution that I created in activity 10. This one. It's still indicating it's about 22 degrees. The color is blue on top, green in the middle where it touches the sugar, the salt, and then the salt content is beige. It's like a 3-layer. Blue, green, and then salt, beige. I'm gonna add the aluminum metal pieces. There's fizz. You can see the bubbles. And I'm gonna record the temperature of the product. It is rising. This is a physical change. The aluminum rusted. It oxidized. There's a chemical change. Oxidation is a chemical change. It's a chemical reaction. And oxidation is when oxygen is combined with the chemicals. The temperature is 32 degrees. So this is the final product for activity 11. Okay, for activity 12, my test tube is here. My test tube in the rack. I'm going to be using 5 milliliters of copper sulfate again. Using the graduated cylinder for the intervals. Okay, and that's going to go into the test tube. And I'm going to take the temperature of the copper sulfate, which is blue. It's right about 24 degrees. Using a small piece of sandpaper. I have to sand the exterior part of the nail. Okay, there's my nail. It is silver. Temperature stayed the same. I place the nail inside the copper sulfate. And it's going to stay in there for 1 minute. And then I will take the temperature. Hmm. Thirty more seconds. It's starting to change colors. Looks like it's oxidizing as well. It's becoming like a copper color. 10 more seconds. Okay. Sorry, I had to remove it first. It changed colors. The solution stayed about the same 24 degrees, but the nail began to rust. That is a chemical change because it changed the color and began to rust, which means it began to oxidize. If I scratch it, that layer comes off. The temperature rose a tad bit, it's about 25. Find the colors like a copper color. The observation that it began to rust while it was in the solution. That's a chemical reaction. Because it became a new product. At least the part that was submerged in the solution. This is my first data table. This is my second. At the conclusion of this experiment, I can definitely say that the chemicals have all to do with the reaction that's going to occur. Also, what is a big indicator is the amount of time that you let it mix and mingle. the experiment required that you did that for a minute, and if you went ahead, then you got totally different results. For example, in the one where I placed parts of the aluminum, the longer you let it sit there, the top part of the test tube turned like a cloudy gray, and that lime green stayed the same at the bottom, but the metal completely rested. Also, you had to take note of the temperature rising, a difference of about 10 degrees from 22 to 32. And so that was really interesting to see the reaction. Some of them were physical, some of them were chemical, based upon what occurred once you mixed a couple of solutions together. Overall, this experiment was very cool, and it really, just gave you just the slightest idea of what chemists do in the lab. So that was really neat to kind of experience that firsthand. Thank you.